Okay, so today's lesson is on practicing show that questions. So it's focused on exam technique a little bit on this one. We're going to be looking at a particular type of question. So I like to take out your calculators and just get started. So this is a question that we had, or part of a question that we had on our semester exam. I'd like you to have just a warm up and have a go at A, B, and C for this one. Have a go at parts A, B, and C. I'll give you, how much, with 6 minutes for this? 6 minutes for this. Akmal, let's get started. All right, so first up, we need to find the length of OM. So OM we see is this line here. So OM is from the midpoint to the side, so it's going to be the same as this line here. So we can find OM by taking OM is equal to 230.4 divided by 2. That's going to give us 115.2. Secondly, we need to find VM. So VM is going to be flat on that face like this, coming down to this point here. It's at the midpoint there. So we're going to get a right angle here like this. And this is lying on the face of the side. So we've got a right angle triangle now in VOM. So we can use Pythagoras' theorem. And we can find VM as the square root of 115.2 squared plus 146.5 squared. Put that into our calculator, and we're going to get 186 meters. B. So now we have to find the area of triangle VBC. So let's find VBC. VBC is the triangle on this face here. VBC is the triangle on this face here. We've been doing that triangle in the altitude in the center of the circle, of the pyramid. Now we're looking at the triangle on the face. To calculate the area of this, we've just found VM. Now, VM is the altitude of this triangle. It's the vertical height of the triangle. So we can use half base times height for this one. We don't need to use the trigonometric formula of half AB sine C. So if we wish to find the area, that is going to be a half times the base, which is 230.4, times the value we just got. Now I'm going to write 186, but I've just calculated on my calculator. I'm going to use the exact value. Also, previously I calculated what half of the base was when I found OM in the first question. So just to save me some typing, I'm just going to press times 115.2. What are the first 3 digits of this number on your calculator?
214.
No. Sorry, let me see. What am I doing? Oh, I see. Okay. I'm speaking as though I was just calculating it. However, I wasn't. I calculated earlier. All right, let me times this by 115.2. Okay. Again, please, Akmal, you were correct. What were they?
It's 214.
And do we round at that point? What's the next digit? The next digit is 6. So it's 215. How many digits are we missing? We're missing 2 more digits like this. This is 3 significant figures. And it would easily mask any errors that we made earlier, or slight errors. So now we need the volume formula. Now the volume formula says, on the formula sheet, it says a third area times height. When it says area, it doesn't mean any old area you've just calculated. So it's not the area we've just calculated there that we use for this. You have to understand the formula. It says very clearly it's the area of the base. It's the area of the base of the period, not any old formula area you just calculated. So the area of the base is going to be 230.4 squared. And then we have to times by the height of the pyramid, which is 146.5. Type this into our calculator, and if we round to three significant figures, it's going to be 2,590,000, and then we round. This is meters cubed. Okay, so D. Our point today is to look at show that questions. So there's a few styles of show that questions, but these are all about proof. So for this one, we need to show that the angle between the line VM and the base is 52. So the line VM is that one coming down here, and the base, so we are after this, let me just do it in red. We are after this angle here. We are after this, I can't draw this. Let me draw that a bit bigger, give myself some more space. We're after this angle here. So we've got OM, which is 115.2, and we've got VM here, so we can use the tangent function. So a right angle triangle is this, there. We can use the tangent. So the opposite, squeeze this in here, is we have to show that the angle, so we'll call the angle theta, is equal to the tangent of the, is equal to the inverse tangent we've got 146.5 146.5 over 115.2. Put this into your calculator, what do you get?
It's 1.8 over 52.
Okay, so what's important on this question, on this style of show that question, is you have to show that your calculation gets 52. Now you can't write 52 at this point. You have to write more decimal places than 52. So as long as you write a few more decimal places, it doesn't matter how many, one is enough, so 3 decimal places or 4. So you can write like this, 51.82, which equals 52 degrees. So you have to show that this will make 52. So just simply write, if you miss out this piece here in the middle, if you miss out this, you're not showing that it creates 52. You're putting up the necessary method, you'll get the method point, but you won't get the answer point because you haven't produced an answer that will round up to the answer given. So one of the two things that we need to see here on the show that style question is if you're calculating a value, calculate it to more decimal places and show that it rounds up to the value. Secondly, you must always end with the answer given. There's no point for it, but you'll lose the last answer point if it's not included. So when you look at the mark schemes, they don't show a point there, they show AG. And what it means is unless you finish on the answer given, the last accuracy point is not awarded. So make sure for this type of question, you show that it rounds and it will round up to the answer given. All right. Yes. There are multiple ways to solve math problems.
Oh, so it's okay if I just use it and get the same answer?
It's okay if you use a different method and get the same answer. That will work fine. Which cosine rule did you use? Did you use the length Vm?
Yeah.
Yeah, you're just making it more complicated for yourself. Particularly in trigonometry, because everything sort of moves its way around, you often get there. Okay, have a go at this question now. Let me pause the video. Let's have a look at this one. Okay, so here on this one, we're asked, this is a very simple show that style question. We're asked to verify an equation for a given set of values. The best approach for this type of a question is to use a left-hand side to right-hand side style proof. So we will start off on the left-hand side of the equation, which is equal to 3y plus 2x. Staying on the left-hand side, we will insert the values for x and y. So we'll insert y is equal to minus 5. We'll insert x is equal to 6. We'll do the arithmetic. 3 times minus 5 is minus 15. 2 times 6 is 12. If we add these together, what do we get? Let me do it here. If we add these together, what do we get? We get minus 3. Minus 3 is not equal to 9, which is the right-hand side. So take your equation, put your values in, show what it produces, and then say that is not, or that is, what is on the right-hand side, depending on what we're doing. Very simple, straightforward technique. This type of a question, you guys usually struggle on the structure, how to communicate your structure of how to do this calculation. You tend to write the whole equation up to begin with, and it ends up looking a bit confused. So start with one side and evaluate it, and then compare that with the other side. Start with one side, evaluate it, and then compare it with the other side. And this left-hand side to right-hand side style proof is a good way to go about it. All right, let's have a go at this one. Okay, so we need to show that this equation is true. So if we have to figure out a little bit what this equation is about. And it won't take us too long to see that it looks a lot like this equation here. And more importantly, we've got a value of 34. So it's going to be this. We can use a left-hand side, right-hand side style proof again. So the left-hand side is equal to h of, and we're going to put in 2 as our value for t. So h of 2. Now h of 2 is going to be a bracket 2 squared plus b bracket 2 plus c, which is equal to 4a plus 2b plus c, which should equal 34 because h of t is 34. And this is the right-hand side. Okay, let's have a go at this one. Proportional systems. Don't forget this topic when it comes up to your mock. Proportionality. I think Unit 3, Lesson 1. Okay, let's have a look. So this one takes a little bit more. What we have to start off with is this sentence here. It says that I varies inversely with the square of the distance d. So it says I varies inversely with the square of the distance. So as an equation, we need a constant of proportionality, which will be k, and that's going to give us this. Next up, it tells us a couple of values. It is known that the distance of 1.5, so this here is a d. The sound intensity is 4, so this is an I. We can put these values in. We've got 4 is equal to k over 1.5 squared. We can choose to end solve this if we wish, and this will tell us that k is equal to 9, which implies that I is equal to 9 over d squared. Don't forget, don't stop at calculating your k, stop at the answer given. It's very important that you stop at the answer given here. This is what you have to show that. So always make sure you end one of these questions with the answer that is given. Yeah, okay, so with this question, you're going to get no points if you use an approach that uses the question. So you can't use what is given here to show what is given here. You can't use what is given here to show what is given here. You must show that this is developed. So an answer that will get no points, an answer that's going to get no points, it's a good question, that one. It's going to be one that you just simply say 4 equals 9 over 1.5 squared. You're using the question given on this one, so you're not going to get your points for that one. We have to show where this is created from. Okay, have a go at this one. From probability, topic 6. So we need the test for independence from the formula sheet. The test for independence is that the probability of A intersection, and it's using D instead of B here, is equal to the probability of A times the probability of B. This is from the formula sheet. So we're going to use a slightly different left-hand side, right-hand side proof. So the left-hand side is the probability of A intersection D. That is the probability that all passengers arrive on time for a flight and it departs on time. That's given there in the question as 0.65. We'll then move to the right-hand side, which is the probability of A times the probability of B. Probability of D. So the probability of A is 0.7. We need to multiply this by the probability of D, which is 0.85. Putting that into our calculator, we get 0.595. So then we want to compare the left-hand side to the right-hand side. So this implies that the left-hand side equals 0.65, which doesn't equal 0.595, which is the right-hand side. The left-hand side doesn't equal the right-hand side, which implies, and we always have to end with the answer given. Events A and D are not independent. Independent. Okay, so have a go at this next question. Okay, so this show that question has 5 points. Okay, it's going to take a little bit more than normal to solve this one and show this one. If we look at the question, we're given a function. We're given this function here. We're also told that it has a local maximum and minimum, and that the local maximum is at x equals minus 3. So we're going to use that. What do we know about a local maximum point?
Find them using the derivative.
So we can find the derivative. The derivative, what should the derivative's value be at this point?
X squared plus.
No, what should the derivative's value be at this point?
0.
0. One of the key pieces of knowledge for calculus is that the derivative is equal to 0 at local maximum and minimum points. So let's take the function. We've got f of x is equal to a third x cubed plus a half x squared plus kx plus 5. First we need to find the derivative. It's quite an easy one to find. It's going to be x squared plus x plus k. So the local maximum at x equal minus 3 tells us that f dash of minus 3, so let me just do a little bit more. Local max at x equals minus 3 implies that f prime of minus 3 is equal to 0. So if f prime of minus 3 is equal to 0, that implies that 0 is equal to minus 3 squared plus minus 3 plus k, which is equal to 9 minus 3 plus k, which means k is equal to negative 6, which is the answer given. Always end with your answer given. Let's finish it off for B. So find the coordinates of the local minimum point. There's a couple of ways to do this. If I was just going to find the x value for the local minimum, I would probably just use the derivative again. We've got 0 is equal to x squared plus x minus 6 now. And this is going to give us x is equal to, we get two values. We get minus 3 and x is equal to 2. But because we then have to find the y value, it says find the coordinates. It says find the coordinates here. Because we have to find the y value, I've got to type the function in anyway. So why not just type the function in right from the beginning and sketch the graph? So you can type this, you can take this value 2, you can put it into your calculator, and we can get the coordinates to be 2, minus 2.33. Or we just sketch the whole thing. If we sketch it on the calculator, we can see that the curve is going to look like this, and the coordinates here is 2, minus 2.33. So either of these two methods work. We've got two methods here. Either one works. All right, that's it for today.